Today's lesson is on binary ionic compound nomenclature. What that basically means is how we are going to name ionic compounds that contain two ions. In this particular lesson, we will show you the definition of a binary ionic compound, and then we will show you using Inkscape how ionic compounds form. And in that simulation, we will show you how you can write a formula from a name, and then finally, we will show you how to go backwards and write the name from a chemical formula. Okay, what you will see here is I am using the program Inkscape and I've drawn a few shapes here to kind of illustrate the idea of ionic bonding. Now, a binary ionic compound is going to be a compound that contains two ions, an ion being a positively or negatively charged atom. For example, this would be a cation. It's positively charged, and this is the sodium cation. Over here we would see these are anions. Anions are negatively charged ions. So this would be the fluoride ion. Now if you notice I said fluoride and not fluorine, an anion is always named by changing the suffix to IDE, so this would be fluoride. This guy here would be called oxide instead of oxygen. This guy here would be called nitrogen, nitride instead of nitrogen. So what we're going to do here today is we're going to show you roughly how this works. Now, the idea of the reason something is positively charged is because it has lost an electron. So this sodium has a positive charge because it's lost one electron. We're representing it as a little notch here, almost as if there's a hole for where that electron that it lost is now, a hole is now showing what we would have been missing. Over here, fluoride has actually gained an electron, so we're going to use this little spike, or peak, maybe you want to call it, that's going to stick out of the fluoride ion, representing that it has one extra electron. Now, because this has a positive charge and this has a negative charge, there's going to be an attraction because of the laws of attraction and repulsion, opposites attract. We would notice that this fluorine fits nicely right into the sodium on a 1-to-1 ratio. This one sodium had its, we can call it a valley, filled by the peak of the fluoride, and we notice that everybody is satisfied, and we have formed a compound known as sodium fluoride, or NaF. Now this NaF is actually just counting how many of each ion we use. We used Na and one F, making a compound called NaF. Now this NaF is a ratio of 1-to-1, and notice that we don't use the charges. The charges are just used as scrap work. So this would be how NaF was formed. I'm going to move all these at once up to here, just show you kind of roughly what we had. Now let's say I picked two other guys to put together. For example, this time I used calcium, and I wanted to pair calcium with fluoride. Now if I did that, we see that calcium is missing two holes. So, or has two holes, and that's because it is looking for two more electrons. Now this one fluorine would manage to fit in pretty well, and we would see that we used one Ca and one F, but there's still a vacancy here, so we would bring over another fluoride. And what we would see here is that we have two Fs were needed to fill the holes of the Ca. So if we were to count them up, we have one Ca and two Fs, resulting in a compound name or a formula of CaF2. This will be known as calcium fluoride because it is made up of calcium ions and fluoride ions in a ratio of 1 calcium to 2 fluorides. So we've created yet another compound. Again, this is another ionic compound. All right, we'll take a look at one other example here. For example, let's say we were looking at something a little bit more complex, like Al. And with the Al, we see it has 3 positive charges. Aluminum ion has 3 missing electrons. So if we brought an oxygen to pair with it, for example, we would see that the two negatives for O would fill in 2 of the holes for aluminum, but it wouldn't quite fill in the third. So we would need another oxygen to fill that in, but we would see that that would quickly lead to a problem in that now this extra oxygen is here, and this extra oxygen seems to be missing a spot. So we need to bring another aluminum here to fill in that spot that was not filled in yet. And now we have 2 aluminums. And now we can see, you almost might see the jigsaw puzzle pattern forming here. We see that we need one more O to fit in. And what we have is a 3-to-2 or a 2-to-3 ratio. We have 2 aluminums were needed for 3 oxygens in order to make this thing completely balanced out. Now this would form a compound, as you guessed it, Al2O3. Al2O3 is aluminum oxide in a ratio of 2 aluminum cations for every 3 oxygen anions. And again, we'll just call it aluminum oxide. This is the ratio that aluminum oxide would always form in. So what we see here is it's basically a rule of canceling each other out. You have to have as many positives as you have negatives, and if they fit in perfectly, you will name the compounds. Now, a little shortcut method to this I like to call the crisscross method is if you look at the charge values here, for example, Na had a 1 charge and F had a 1 charge, if I just simply traded those numbers and neglecting the charges though, just the numbers, I would have had a ratio of 1 to 1. And that gives me NaF. If I look here for calcium fluoride, I had a positive 2 charge and a negative 1 charge. If I just traded those numbers, what we would have seen here is that you would have had a 1 would have been transferred to the Ca, so it would be Ca1, and then the 2 would have been transferred to the F, and it says CaF2. We call this the crisscross method, and I'll explain this a little bit more in class. But basically, if you just trade the numbers and not the charges, you would always come up with the formula as a shortcut. Same thing with the aluminum and the oxygen. Again, notice that the 3 was aluminum's charge value, and the 3 ends up in the O's formula. The O's charge value is 2, and the 2 ends up in the Al's part of the formula. So this is Al2O3, again, what we call the crisscross method. Okay, for our final part of the lesson, we're just going to show you the simple way of writing the names from a given formula. If you look here, I have 3 different formulas that are written down. We have MgCl2, and that is going to be called magnesium chloride. We have AlBr3, and that will be aluminum bromide, and Na2S, and that is sodium sulfide. If you notice here, the rules for ionic nomenclature is actually quite simple. Once you identify that you have an ionic compound, and an ionic compound is simply noticed is if you have a metal as your first ion and a nonmetal as your second, and if you looked on your periodic table, we do have that criteria, metal and nonmetal, metal and nonmetal, metal and nonmetal. The rule is very simple. All you need to do is name the 2 ions that are involved in the compound. This would be magnesium, and again, chloride, not chlorine, chloride because the anion is changed to IDE. So this is magnesium chloride. Again, aluminum and bromide makes aluminum bromide. Sodium and sulfide ion is sodium sulfide. Okay, I hope you have learned a little bit about ionic nomenclature. Please make sure to refer to the notes that are posted on my webpage and also take the required comprehension quiz at the end of this lesson, and we will discuss this in class.